The Cloud Aerosol Transport System, or CATS, is a new instrument for the space station that will measure and characterize the worldwide distribution of clouds and tiny aerosol particles, or tiny atmospheric particles, in the Earth's atmosphere. CATS is a spectacular opportunity to utilize the space station infrastructure to obtain important Earth science measurements at a modest cost. As the first instrument for Earth science to be developed at Goddard Space Flight Center and installed on space station, CATS will provide capabilities that haven't been demonstrated before from space. CATS is a laser remote sensing instrument, or LiDAR, that provides measurements of clouds and particles in the Earth's atmosphere. LiDAR works a lot like radar, except we use low energy pulses of visible and near visible laser light. The CATS instrument consists of two lasers, each having different characteristics, a receiving telescope, and special photon counting detectors. Overall, CATS packs a significant scientific capability and a lot of technology into a package about the size of a household refrigerator. LiDAR works by sending discrete pulses of laser light into the atmosphere and then detecting the small fraction of light that scatters from particles. CATS will generate profiles of clouds and particles in the Earth's atmosphere to identify the presence and height of clouds and particulate layers. Detailed observations of clouds and particles in the Earth's atmosphere are important for many reasons, but three key uses are for providing information on real-time hazard events such as volcanic eruptions, for studies of energy balance, that's climate change, and for examining the effects of man-made and natural pollutants on air quality, health effects. Let's take each of these 3 points in order. For example, CATS can determine the top and bottom height of volcanic plumes. That information can be used to make better decisions on airplane routings and cancellations. The volcanic eruption in Iceland in 2010 resulted in almost 100,000 canceled flights and cost nearly $2 billion because airlines dare not send planes anywhere into or near plumes for fear of damaging the engines. Second, CATS permits studies of clouds. Clouds are one of the largest uncertainties in predicting climate change because clouds are the key regulator of the planet's average temperature. For scientists to create more accurate climate models, they have to include better representations of clouds, which means they need more information on which to base their models. And third, small particles such as dust blown from deserts, smoke from intense forest fires, or man-made pollutants can have significant impact on the Earth's climate and on human health and air quality. CATS data will also be used to improve computer models of clouds and aerosol particles. Right now, the vertical distributions and the microphysical properties of atmospheric particles are often poorly resolved by computer models. To improve the quality of the simulations requires real-time data about the particle type and height. LiDAR can provide that vertical distribution, and we know that will address one of the biggest weaknesses in the models at this moment. The space station orbit is a good fit for CATS because the station transits over and along primary aerosol transport routes in the atmosphere. Data from CATS will be transmitted to the ground continuously and in near real time to be promptly assimilated into computer models to create improvements in those models. That real-time data capability is made possible by the space station communications infrastructure. On the whole, CATS is a cost-effective way to demonstrate new technologies and new measurements that will inform future satellite missions. The build-to-cost approach embraced by the CATS team is a fiscally responsible way to obtain important Earth science measurements, and being able to utilize the space station as a platform begins a new and exciting era for Earth science. And that, in a nutshell, is the why and the wherefore of CATS. CATS is set to launch later this year on SpaceX 5, and we are very much looking forward to this exciting new Earth science capability.